Alright, so I'm going to be going through the first section on Unit 11, which is trigonometric graphs. We're going to be talking about the graphs of basic trig functions. Now these are a little different than anything you've done before because they have periods and amplitudes and some stuff changes around. But we need to know the basic graphs before we get to any of that. So these can be derived from the unit circle, which is here. And you'll notice that a couple of things. First, you'll notice that the inside here gives us our degree measures. That inside circle is the degree measures. Not really super well done. The outside circle here is in radians, which we actually use radians when we're doing trig graphs. Don't ask me why, that's just the way that it's done. So we use radians, and this can show you the conversion between degrees and radians. So 45, 60, 30, everything going all the way around. And then on the outside here, we already have our cosine and our sine values for everything. So the first two graphs should be super easy if you look at this diagram, which is in your notes packet. So instead of using degrees, however, radians are used. So that should be the first thing that's in your packet. Instead of using degrees, radians are used. I know that's not in here because my set of notes is a little bit different than what I handed out to you. So we're going to start with sine of x. So in a trigonometric graph, the domain x values consist of the angle measures in radians. And the range, the y value, consists of the sine value at each angle. So the domain is going to be all of the reals, because you can have any angle measure you want going from negative infinity all the way up to infinity. The range, however, is going to oscillate, and oscillate means go back and forth between -1, so -1 is less than or equal to our y value is less than or equal to +1. So when we start graphing this, you're going to see that it starts at a value and it's going to go up and down, and then it's going to go back up and then back down. So it's very repetitive, as you'll see in just a minute here. So I want to look at, for sine, so our domain is going to be all of our x values. So we have our angle measures up there, and sine of x is going to be the second part of our table here. So at 0, sine is 0. At pi over 2, which is 90 degrees, sine is 1. At pi, which we know is 180 degrees, we know that sine is back to 0. At 3 pi over 2, which is 270 degrees, pi is -1. And back to 2 pi, which is 360 degrees, we are back to 0. So we're going to go ahead and mark these out. So the first thing you want to do is, well, we know where 0 is, which is right here. So let's go out 1, 2, 3, 4, 5, 6. And this is going to be pi over 2. Go another 6. And this is going to be pi. Go another 6. This will be 3 pi over 2. And then another 6. And we will be at 2 pi. Okay, I picked 6 because it fit on here nicely. If you actually went another 6, you would be to 5 pi over 2. And we'll get to that in just a second. So now we're going to graph. So we know that at 0, sine is 0. So we'll put our first point here. We also need to mark our y-axis. So let's go up 1, 2, 3, 4. Let's go up, say, 5. And this will be 1. And then go down 1, 2, 3, 4, 5 spaces, and that will be -1. And you can make these graphs however you need to fit on the grid that you're given, because sometimes they'll be taller, sometimes they'll be shorter, depending on what exactly you're graphing. So at pi over 2, we know we're all the way up at 1. So we're up here. At pi, we're back to 0. At 3 pi over 2, we're at -1. And at 2 pi, we're up here at 0. So if I made you guess, if I forced you to guess at 5 pi over 2, where would you be? I want you to go ahead and graph that point, and when we do this, just continue your curve onto that, and we'll talk about it in class. So, as you heard me just say, this is a curve, it's not a straight line. So do not connect these with straight lines, because that is not correct. It's called a trig curve. So it curves up, and then it curves down, and then it curves down some more, and then it curves back up, and then go to wherever you think the next one would be. Okay, I'll give you a hint. It doesn't change directions automatically. It's got a curve to change directions. So this is the graph of y equals sine of x. And as you see here, it says from 0 to 2 pi. So we started at 0, and we went all the way up to 2 pi. So you'd actually stop there based on the domain that you're given. So let's look at the next one, which is cosine of x. So the graph of y equals cosine of x is similar to sine, except it is starting at 1. So it's very similar, but it's starting at 1 instead of starting at 0. So again, the domain is all of the real numbers, and the range again is -1 is less than or equal to y is less than or equal to 1. So when we fill this in, we have our x value, and now we're doing cosine of x. So cosine of 0 is 1. Cosine of pi over 2, which again, that's 90 degrees, is 0. Cosine of pi, which is 180, and eventually I'm going to stop writing the degree measures in there. You're going to need to know it in radians. So at pi, we're at -1. 3 pi over 2, which is 270, we are at 0 again. And 2 pi, which is 360 degrees, we are back up to 1. So again, we're going to mark it up exactly the same. So 6 spaces will be pi over 2. Another 6 will be pi. Another 6 will be 3 pi over 2. And another 6 will be 2 pi. And if you go all the way out, that would be 5 pi over 2, which again I'm going to ask you to guess on. Again, we'll go 1, 2, 3, 4, 5 up will be 1. 1, 2, 3, 4, 5 down will be -1. And we're going to go ahead and graph what we have here. So this time, just like, or very similar to the sine, cosine starts at 0, 1. So we start up here. And then we're at pi over 2 and 0. Pi is at -1. 3 pi over 2 is 0. And 2 pi is +1. So again, I'm going to have you guesstimate. Go ahead and guess where you think 5 pi over 2 will land you. And then the next thing you can do is go ahead and draw in your curve. So make sure that you're not connecting with straight lines. Maybe do a little better job than me. And that is our graph of y equals cosine of x from 0 to 2 pi. And you'll notice that if our line had been drawn here, and we had gone a little further, this would actually match up exactly with sine of x. So we're going to do something a little different. I'd actually like you to try this on your own. Is graph y equals, and in yours it says cosine of x. So y equals cosine of x, the interval from -pi to +pi. So I'm going to give you a hint. We're going to start here. Let's make this -1. Make this +1. And if you go 6 out, again, this will be pi over 2. Go another 6, and this will be pi. Going backwards now, go backwards 6, and you're at -pi over 2. And backwards another 6, and you're at -pi. So that is what your scale should look like. What I'd like you to do now is go ahead and graph cosine of x on that. And you should already know from what we just did a second ago that this half looks something like this. So go ahead and graph what you think that other piece is going to look like, and we will go over that in class tomorrow. The last thing I would like to go through is tangent. And tangent is different than sine and cosine, because as you remember, there's some undefined values in tangent. So for tangent, our domain is a little different. Our domain is all reals such that sorry, I should have this. X does not equal pi over 2, 3 pi over 2, oops, 5 pi over 2, dot, dot, dot. And our range, again, is going to be, now this will actually be all reals because tangent can go higher and lower than 1 and negative 1. So since tangent has angles for which it's undefined, the graph will have asymptotes. Asymptotes. And remember, that's something where the graph gets really, 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 really close to it, but never actually touches. So, if we are graphing y equals tan of x, if we remember at 0, we are at 0, and at pi over 2, it was undefined because it's sine over cosine, and cosine at pi over 2 is 0. At pi, we're at 0. At 3 pi over 2, we're undefined. And at 2 pi, we're back at 0. So we're going to set this up very similar to what we did before. Here's 1. Here's negative 1, going out 6. We have pi over 2. Another 6 is pi. Another 6 is 3 pi over 2. And another 6 is 2 pi. So, our asymptotes are actually going to be where it is undefined. So let me make this a dotted line here. So our asymptotes are going to be at pi over 2, so we'll have an asymptote right here. And at 3 pi over 2, so we'll have an asymptote right here. And then actually, again, you would have another one here at 5 pi over 2, but it doesn't ask us to graph that. It only asks us to go from 0 to 2 pi. So we are starting at 0, 0. At pi, we're at 0. And at 2 pi, we're at 0. And if you actually start plugging some values into your calculator, as you get closer and closer to, remember this is 90 degrees, as you get closer and closer to 90 degrees, your number gets higher and higher and higher. So it actually looks something like this. Now, as you go just over 90, so like 91, 90, 90.5, you're actually getting a bigger and bigger negative number, so it curves down like this. And again, this is a repetitive function, so then it would curve up. That was a really bad curve. And it would curve down. So I want you to go ahead and graph what you think it would look like in this section right here, and we will talk about that in class. But as far as this is concerned, from 0 to 2 pi, that is what our graph would look like. It kind of looks like, I don't know, propellers a little bit, I think. Whatever you think it looks like, but this is the crazy one that goes up to infinity and down to negative infinity. The last thing that I would like you to do is to graph these two functions, which are tan of x and cosine of x, on the same graph, going from negative 2 pi to positive 2 pi. So if we set up our scale here, if we make this positive 1 and this negative 1, now we can't go out 6 or we're not going to get them all in there. So we actually can only go out 3. So this would be pi over 2. This would be pi. We'd have 3 pi over 2. And then we would have 2 pi. And then going backwards would be the same thing. Backwards would be negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So we've actually already done tangent and we've done cosine. So you need to go through and make what your graphs look like. So the tangent graph, we already know, on this half looks something like this. And the cosine graph, and it will be a good idea to use two colors. Use two colors to do this so that you know which one is which. So I did half of the tangent there. The half of the cosine graph, if I use a different color, goes something like this. So I want you to go ahead and you need to fill in the other half over here for both of those, the cosine and the tangent graphs. Other than that, we will talk a little bit in class tomorrow, and I hope you have a wonderful evening.